Hey, what's up? Today we're going to be looking at very tough questions in reading and writing. I'm in the student question bank and I set the difficulty to be hard. So we're going to see the hardest questions. Starting with this one that I just reviewed. So we have The Poet Whitman is an essay. Okay, it's an essay from 1887. Yep. Author, okay. Political activist, okay. So we talk a bit about the author. We talk about what he wrote. He wrote an essay in Spanish, and in the essay, the author Marty explores the value of literature. Literature is writing and reading, like poems, novels, and essays. So he explores the value of those kind of things, right? How valuable are they? He argues that as societies, like people, society's spiritual well-being, the spiritual well-being is like mental well-being, your inner body, inner soul. So he argues that mental well-being from people depends on the character of its literary culture. It depends on the character, on the way it is, their literary culture. That means, so this is not too hard to understand. He says that the mental well-being of a society depends on what they read and write about. Right? What are they reading? What are they writing about? That's the character of the literature that they are consuming. So based on that, that's gonna determine whether or not they have well-being mentally, spiritually, right? So then the question asks, which quotation forms a translation? Which quotation from a translation of the poet Walt Whitman most effectively illustrates the claim that the well-being of a society depends on what they read and write about. So let's read option A. Poetry which brings together or separates, which fortifies, makes stronger, or brings anguish, sadness, right? Which shores up, which strengthens, or demolishes souls, which gives or robs men of faith and vigor, like energy, is more necessary to a people than industry itself. For industry provides them with means of subsistence, money, jobs, that's the industry, while literature gives them the desire and strength for life. So let's go slowly through this one again. It talks about what poetry does to people, right? It can be good for them or it can be bad for them, I guess, depending on what they read about, depending on what the poems are about. So it can do good things and bad things to people, but it is still more necessary than just subsisting, than just having money and food. It is still more important than that because it gives you strength for life, right? Strength for life, that means it gives you mental well-being, it gives you spiritual well-being. So this is a perfect answer. Because it says, all the things that poetry can do to people, and it says that means it can literally change or determine the way people are and their well-being, because it gives them strength, and it is more important than just industry itself. Option B says every society brings to literature its own form of expression. Now this is kind of confusing to me because it says every society brings to literature its own form of expression. This is saying like society chooses the form of expression. Society brings to literature its own form of expression. To me that didn't make too much sense. Literature is supposed to bring society their behavior, their mental well-being. And the history of nations can be told with greater truth by the stages of literature than by chronicles. history of the nation. So it's just talking about history. It's not really saying anything that matches or that confirms, that illustrates the claim we just talked about in option A. Option C, where will a race of men go when they have lost the habit of thinking with faith about the scope and meaning of their actions? The best among them, those who consecrate nature with their sacred desire for the future, men will lose in assorted and painful annihilation. This doesn't even mention literature or what it does to people. Listen to the song of this hard-working and satisfied nation. Listen to this person, the exercise of himself. Tolerance exalts him. It doesn't even talk about literature again, so these two don't even talk about the thing we want to illustrate. This one illustrates the wrong thing. This one is the only one that's correct. Okay, next question that wasn't actually too hard either. It looks hard because it has a lot of jargon, like superfluorescence, dipoles. What else is jargon here? There's something else. Thermal interference, shock absorbing particles, polarons. Let's read this. So electrical charges known as dipoles emit light in synchronized bursts. So we know that whatever this is, they emit light in synchronized bursts. So intense that you can see them. They are visible to the human eye. Until recently, though, this phenomenon has only been observed at extremely cold temperatures, because dipoles cannot synchronize at higher temperatures. So you can only see dipoles emitting light with your human eye if it's at an extremely cold temperature, not a warm temperature, because they cannot synchronize. And they need to synchronize their bursts. They need to synchronize their bursts. But in a study, colleagues observed that they observed the thing, right, the dipoles, at room temperature, basically at a warmer temperature, in thin films made of that and other similarly crystalline materials. So we know this is a crystalline material. We know that they observed it at a warmer temperature in crystalline materials. The researchers proposed that the formation of shock-absorbing particles, so the formation of the particles called polarons, we don't care about this, we just care about the particles being called polarons in the material, protects dipoles from thermal interference. This is just a scientific word for heat, right? So this is saying that polarons are particles that are in crystalline materials, and they protect dipoles from heat. So technically they're cold inside the material, and that's why they emit light, although the materials themselves are in a warmer temperature. So based on this, how are polarons believed to be involved in the superfluorescence? So they are involved in, so that before even looking at the answers, they're involved in a way that protects them from heat, so they can be visible to the human eye. Okay, let's see. Polarons enable superfluorescent bursts to cross from one crystalline material to another. No, they don't cross from material to material. Polarons allow for dipoles to synchronize despite higher temperatures. That's right, they basically allow them to work, although they're at a warmer temperature. Polarons accelerate. No, we never talked about any acceleration of the bursts. Polarons decrease the intensity. We never talk about the intensity being less. We are saying they are intense, and that's it. So option B is correct. Right, next question. Given that stars and planets initially form from the same gas and dust in space, some astronomers have posited that host stars, such as the Sun and their planets, such as those in our solar system, are composed of the same materials. So this first part is saying that stars and planets form from the same gas and dust, so the same materials. Some astronomers have stated that host stars, like the Sun and their planets, have the same materials, okay? With the planets containing containing equal or smaller quantities of the materials that make up the host star. So the planets contain equal or smaller but not greater quantities of the materials that make up the host star. This idea is also supported by evidence that rocky planets in our solar system are composed of some of the same material as the sun. So in our solar system, some of the rocky planets are composed of the same materials as the sun, which finding, if true, would most directly weaken the claim. The claim is that they have the same materials and they have equal or smaller quantities of those materials that make up the host star. Let's read option A. Most stars are made of hydrogen and helium, but when cooled, they are revealed to contain small amounts of iron and silicate. This is not comparing the host stars to the rocky planets. This is just saying what stars are made of, but we never know if the planets are also made of that, or what the quantities of those materials are in the planets. So no, wrong. B says a nearby host star is observed to contain the same proportion of hydrogen. A nearby host star is observed to contain the same proportion of hydrogen and helium as that of the sun. Nearby host star is observed to contain the same proportion. So there's a host star, and it is observed to have the same amount of hydrogen, the same amount of the same material as that of the sun. So the sun is a host star, and we are comparing it to another host star. We shouldn't be doing that. We should be comparing host stars to rocky planets. So it's wrong. Plus, it does obey the rule that they must have equal or smaller quantities of the materials. So let's see option C. Evidence emerges that the amount of iron in some rocky planets is considerably higher than the amount in their host star. Okay, we are comparing host stars to rocky planets, and we are also saying that rocky planets have a higher amount of iron than their host star does. And that would weaken the claim that says here that planets containing equal or smaller quantities, right? That would weaken that part of the claim, and so that would be the answer, option C. Let's read option D. The method for determining the composition of rocky planets. Okay, we never talk about the method here, and we never want to talk about the method. Is discovered to be less effective when used to analyze other kinds of planets. We are not talking about other kinds of planets. We are just focused on the rocky planets. So option is C.